Dear viewers, welcome back to School of Civil Engineering. You all know that already we have created a tutorial series about SDSM, a statistical downscaling model to design our future climate, and they have almost 7 video, and I have got some mail and also comment that please make new video. The sound quality is not good, or the background music are high. That's why that's not clear, and also they don't understand properly. That's why I'm just doing a new video, and I hope you will stay with me. So here I have taken data from 2009 to 2019, and this is maximum temperature. Okay, so I am actually doing that analysis, and also if I just show you something about that, here data, then temperature, then maximum. If I show you about something that, so already I have worked with many stations. So here is the graph of data for RPC, RCP 4.5 and RCP 8.5. So here is the data. Actually it is the graph, and also this is the data, and I have predict for 2040, 2060 and 2080. So this is our temperature prediction data, and I will just create similarly like a chart like that. So stay with me, and I hope you will learn something from here. Actually I have started creating that video because they have no proper, or they have no perfect video to learn about that climatic modeling. So that's why I have just created that, and after my I have done research on it on my PhD level. That's why I have created video. So, and before starting, one request to you: if you're new to our channel, then subscribe to our channel, also press the bell icon so that you get every update ever fast. So first of all, I'll open our software. Okay, and before starting that work, you need to do something. You have to manage that data. You need a data file with your data, and how you will manage your data, I have already created a video. That link are given in description. So I hope you know that how to manage your data. Actually you will get your data like horizontal or horizontal in row. Okay, so you have to make your all data. So if I show you about that, you have to make your all data in vertical row, and here this is the first date of, this is the first data, and this is the one on 2016 data. And if I go the last, so just see here I have 4000 here. If you see here I have 4017 data. Okay, and this is the last day of our data. This is the last day maximum temperature, 31 December 2019, and the first date was 1st January 2006. So actually I said 2009. So that is our total data, and if you calculate that, our total day will be 4017. So in this way you have to make a data file, right? Software, and also the process of creating data file, that video are also given in description, so you can watch that. So when it's okay, when your data file okay, then you have to start your software. And before starting that work, I will request you, please read that user manual, SDSM user manual, and here everything is given. Actually just see here almost 91 page here, 94 page, and in that 94 page they have discussed everything about climatic models. So if you read that, if you read that, then you will be able to work perfectly, and you will understand everything. Okay, so I'm closing that, and one thing you have to do before starting, just you need that GCM data. Okay, for your, for which point you are working, for that point you need that GCM data. You will get data, you will get that data from two places, from SDSM website, okay, and another is from Canadian website. So I prefer to download that from Canadian website, because there you will get your data perfectly, and you will be able to select that data from their graph, so from their map, okay, for your coordinate. And how we'll download that video are also given in description, so you can download that file from there. So we need the two file to start work. Okay, so when your two file is ready, then we'll start our software. So first of all, you have to when you will start, you'll see an interface like that. So first of all, you have to come here, setting. Okay, so from setting, just you need to change something, year length. So when we are going to start our project, then you have to select calendar 366. That means you have a, in your data, if you have leap year, then you have to select that option. Okay, just here it's coming calendar year recognizing leap year. Okay, so when we have leap year, and you know that in our when you will collect that your temperature, rainfall, or any data. Okay, you have to collect that data from meteorological department, and they will manage that data with leap year system. Okay, when at which year you have 29 days in February, then obviously they will consider. Okay, so that's why we'll select that length. Actually you will you'll get that everything in user manual, so I'll request you to read that. And after that, standard start date. So what will be the start date? Actually this is the start date of our data, and this is the end date of our data. Okay, so we have data from 1st January 2009 to 31 December 2019. So here is our data, and from here we'll select our directory. How? So from here, if we see if we select C drive, okay, if we select drive C, then from here we can we are seeing here the SDSM. From here, if we click here C drive, double click, then you will see user. From user, here is the PC username, so the SM Hedaetullah, and from here I'll go desktop, and here this is my that file where I have saved that file actually. So this is desktop, and from here I'll just select data, and from here temperature, and for maximum temperature, and I am doing for that station number 6, and already have completed that 5 station, and I'm just showing you about that station. So I'm selecting that, so it's okay. So when it's okay, and here you have to give here allow negative values. Okay, so I'll tick here for allow negative values, and even threshold. Even threshold will use even threshold 0 for temperature, and 0.3, listen me carefully, 0.3 for rainfall when your rainfall data is millimeter per day. Okay, millimeter per day. And why we'll use that that are available in description, that are available in details in user manual, so you'll read that. And here is the missing data identifier. And actually what is that? Suppose for in case they have no data in one day, or for any technical causes, your meteorological department can't identify the temperature or rainfall some days, then we have to tell that software that in that day we have no data. Okay, so in that day we'll use -999. And if you see our previous our video from discussion that how to manage data, then you will understand about that. And for temperature will not take here, and for rainfall will take here. Okay, so when it's done, after that we have to, I'll save it. Okay, and I'll go advanced. So from here, for temperature we'll use none, and for rainfall we use 4th root. And here for optimization algorithm we'll use dual simplex for temperature, and for rainfall we'll use ordinary least square. So when it's done, and everything is okay, I'll go back again. I'll go back and we'll start work. So first of all we'll do our quality control. Okay, so this is the first part of our quality control. So here I'll click select, and from here I'll select our file from the directory. So here the file I'll open, and after that I'll simply click check. So here it's telling us the 4017 values processed in Naglo max temperature. Okay, 2009 to 2019. So whereas the total value, and if you calculate the total days of that 11 year, then you will find out that value. Okay, so I'll just simply click OK, and now it's telling us here the missing value. So they have no missing value. If they have missing value, then you'll see here, and here is the minimum temperature, there's the maximum temperature of that center, and here's the main. Okay, everything is available here, so our data is fine. So it's telling us number of value, okay, 4017, and if you have some missing value, then you'll see the value after minus that value of your missing value. Okay, so when it's done, now it's done. Actually, after that we'll go here. Actually, they have option transfer data. So if you need to change your data in another any format from here, then you can use that format. Okay, so long, log, square root, okay, root format or portion format. Okay, so you can use that option. Okay, you can use that option to transfer your data, but we no need to transfer. So simply I'll go here, screen variable. So when I'm in screen variable, okay, when I'm in screen variable, so after that I have to select the file, select file. So I'll simply click select. Actually, what is the screen variable actually? So before, actually video are being very lengthy, and I hope you will stay with me and you will understand everything about that software. So actually, what is the screen variable? If you read from user manual, then you will understand perfectly, but I am just telling you something. Okay, you have the predicted file, I mean your that observe field observe file, that is known as predicted file. And also the researchers, okay, or the scientists, they have created some predictor variables. Okay, so by using that predictor variables, we have to find out the suitable, most suitable 2 or 3 correlation between them. Okay, and with that we'll work for our future, because you know that in that predictor they have many variable like temperature, I mean mean sea level, then they have atmospheric pressure, then actually they have many things, then many variable, and humidity, and they have many things actually, wind flow and wind pressure, there are many things actually. So we know that temperature or rainfall, everything depend on that variable. So we have to find out the 2 variable which are most suitable. That's why we are doing just screen variable. Screen variable, by reading that option you can understand that we are screening our 2 variables. Okay, so from here I'll select the predicted file. Our predicted file is dart file, so open. After that that is okay, and from here I'll just go down little bit, and here is our data GCM. I'll double click, then I'll scroll our mouse, then here NCEP, with that data will screen. Okay, so from here first of all I'll select 11 data from here, because that software provides us the opportunity to select 12, but we have 626 data. That's why first of all I'll select 11, and after that just see here, if I select more than 12, then it's tell us it's not possible. So we have selected from here, if you see here. Okay, so if you see here from here that we have selected 11 variable, and as we have 26, first of all we'll select 11, and from that 11 we'll consider 2 predictor which are most suitable. After I mean the rest, after that next 11 we'll also consider 2, and the rest 4 will consider 1. So after that I mean with that 5 predictor variables, we'll again analyze and we'll finally select 2. So I hope you understand. So when it's 11, and here for temperature it should be unconditional, and for rainfall or precipitation it should be conditional. So when it's done, now I'll simply click here analyze. So I'll click here analyze. So our analysis is done. Okay, our analysis is done. Then I'll go back. After that I'll click here correlation. Actually I just want to show you something. If I click here analysis, actually what is the analysis? Actually the analysis is telling us that which predictor are affecting which month temperature. Okay, so if you see here, our this first predictor is name is NCEP MSLP, I mean mean sea level pressure. Okay, so it's affecting our October temperature. So actually that is the issue here, and we'll find out the most relative I mean most correlative predictor from here. So when it's done, after that I'll go correlation, and here is the most important thing you have to understand. Okay, suppose they have 2 things, we'll not see here, we'll see here, because by using that 2 row value we'll find out our 2 predictor. So actually how we'll consider that? So if you see here, they have p value and they have partial r. So first of all, if there have more than 2 0 value of p, you see that there are many 0 value, but in some case I mean when you go for rainfall analysis, then you will not get here I mean your data will not be like 0 everywhere. Okay, even I have an experience like that, there's no 0 value in p, but here we are finding more 0 value. So what is the condition here? We have to find out the 0 value for p, 2 0 value. Okay, if they have more than 2, we have to find out 2 0 values. So they have more 0 values, so p value should be 0 or minimum. Listen me carefully. P value should be 0 or minimum. We have to find out that 2 minimum p value with respect to partial r. And here when if suppose they have a fraction value of p, and from there we have to simply we'll find out the minimum 2p value. But when we have the similar value like here 1 0 2 3 4 5 6 7 8, so we are seeing that in 11 variable we have to, almost 8 p value that are 0. So from here but we have to select 2, so I will select. So when you will find like that, then our partial value should be maximum for that p value. Are you clear? So here for which 0 value our partial r is maximum, we have to find out that. So first of all, I'll see here that is all are minus. So all are minus, so as all are minus, and here they have one positive value, but it is not 0, so we'll not consider at now. But when we have no 0 value in p, then we'll consider the minimum one. Okay, minimum 2. So when it's done, I'll just go here. It is 0.69. okay, it is 0.69. that is not maximum. There have 0.084. okay, and I mean 0.8, and if I go ahead, this is 0.2, but it is 0.2, will not consider that. And here also 11, 12, 0.15, 0.12. I think that is the most, I mean the maximum value 0.084, and they have another maximum value 0. minus 0.111. okay, so I will write that's 2 variable in a paper for our further use. So I hope you understand about that. So what will be actually NCEPP 1 UZL, and another is the below one, that are NCEPP 5 ZGL. okay, 5 ZGL. So when it's done, then I'll go back and I'll just deselect by clicking here. okay, I'll deselect that 11 variable. okay, and I'll select the rest 11. okay, from here 9 10 11. So here we have selected 11, and again I'll go analysis and we'll go back, then correlation, and from here, okay, just see here in this time they have many value that are not 0, right? But we have 0 value in 1 2 3 4 5. Okay, so our 6 value are not 0, but in previous term that is almost all value was 0. So from here, first of all, I'll select that 5 0 value, that one, that one, that one, that one, and that one. So that 5 are 0, and from here we'll find out maximum. So here for the that predictor, we are seeing that this is 0.705, and actually that is the maximum. So I'm just first writing that name NCEPP. okay, NCEPP 500 ZL. okay, and the other one will be, they have 0, this is 0.047, they have 0.2, and they have 0, but the rest on, okay, the rest on are maximum. okay, the next maximum, so we have found out 2, that is NCEPP RCPZL. okay, so it's done. When it's done, I'll just go back and I'll deselect wall variable again, and I'll select just a simply click, double click, okay, done. And that is our the rest 4, okay, last 4. So again analysis, we'll find out one from there, and correlation. So here you can see that they have 2 0 value, 0 p value, okay. So from here we'll select one. So just see here the for 2 0 p value here top and bottom, here the first one is minus 0 point, that is and here 0.701, that means that is the maximum partial R. So I'll find out that NCEP temp PZL. Okay, the last one. So we have found out 5 predictor. I'll just simply select them. After that I'll just go down, or another one is where that one, and other one is we'll select that 5 what we have selected, and other one is 5, and another 5 ZGL, 5 ZGL, here is another one 5 ZGL, and the last one is 1 UZL there. So we have selected 5. Now we'll go for analysis. Actually this is the most important part. Then I'll go correlation. So just see here, if you see here now, the same process we will follow here. Just see here, when we have selected, their value was all was 0 for p value, but now it's not 0. So I'll select they have 3 value which have 0, okay, and from here I'll select the most I mean with that 30 value, what is the maximum for partial R. So just here I think the second one is maximum 0.358, and the last one 0.58. So the second one and the last one, second one and last one. So I think we have found our 2 data. I'll just close. So when it's done, and if you need any data like a scatter, then how we'll take that actually for a scatter. Okay, so actually with respect to which predictor variable you want to find your scatter. Suppose for mean sea level pressure I want to find our scatter. Simply click your scatter. Just see here, this is your scatter graph, and if you need that you can save it. I'm just taking a screenshot because I need a file. So here then I'll save it, means sea level pressure, the maximum, and for the last one save. So it's done. I'll just close it. I'll go back. So when done, then we'll go for calibrate model. Okay, from here we'll by using that to selected predictor variable, we'll just do that. So from here, first of all, we'll select predictant. This is the dot file predictant, and select output par file. We'll select output par file, where we'll select. So here I'll just file name. I'm just randomly select the file name from here. Let's say I'm just doing like that. You can write here file name as per your requirement. So this is the par, this is the file name, then save. Okay, and it should be okay. Prior, that is okay also. Now from here I'll select that 2 file, then GCM data, then NCP, and from here I'll select that 2 file, that is 5 ZGL. Okay, that was 5 ZGL, and another was maybe that one, yeah, NCEP temp ZL. So our 2 file is okay, and now we have to do here something. Our model type, which types of model I want to take. Model type monthly, seasonal, or annual. So I just want to take model type monthly. Okay, then process, here the process that should be under unconditional, monthly, and auto regression. Okay, so you know have that option auto regression, it will be include, and if you don't know, then you have to read the user manual. And here shortest, I'll just use calculate. So when it's done, simply I'll click here calibrate. Okay, so our the model, and see here a file have generated. Our calibrate model is okay. Just I'll go back. So when it's done, now I'll go scenario generator. Okay, so by using scenario generator, actually what is the work of scenario generator? We'll be able to find out our predictor model or our observed model from here by using that file. Okay, so before working that option, before working here, I'll just come here and I'll change the file 365. I will now skip, I'm ignoring the leap year because I'll just save it. Okay, I'm just going back. Why I'm just skipping leap year? Actually, as per the software requirement, we have, when we are going for scenario generator or weather generator, then we have to use that date. Okay, 365, because we are using some, we'll use here some data. If I select here, we'll use that historical data, Canadian ESM2, ESM2. For ESM2, we have to use, we have to ignore leap year. Okay, this is the criteria of that software, and if you read the manual, then you will understand about that in scenario generator section. So when it's done, now when select our input file, we'll select our par file here, and from here I'll select that historical. Okay, because our observed data is historical data. We'll compare, we'll create out file with our historical data. Okay, so when it's done, now you can view, actually this is our predictor, this is our data file, and two predictor we have selected. This is our predictor variables. So, and from here select out file, I'll click here out file, and again I can click here all file to take the name from here. I'll just delete that one. So again I'll click here out file and open. So it's done. Okay, everything is done. Now I'll simply click here generate, and yes, before clicking yes, please select 365 days in year, skip leap year, then yes. So when it's done, okay, here we have found two file, or out file and another is sim file. So okay, when it's done, now by using that file we are able to find out our data, okay, for observed data. So I'll just click here summary statistic. From summary statistic, I'll just select modeled, and from here I'll select that out file. So this is out file, and this is your analysis period. What will be the analysis period? Here is the analysis period, and from here select out file. We'll produce some text file from here. This text file, I'm just clicking wall to take the name from here. Okay, it's done, and must from here select text file. Okay, so actually I'm just taking the name here, just nothing but it. Then you can give a name observed. Okay, you can give its name observed. So open. When it's done, and here is the analysis period. Our analysis period is 2009 to 2019. Okay, then I'll just simply click here analyze, and here a text file will create. So just here a text file have created, and here is the data. This is telling us the main value of that temperature. This is the main, and this is the maximum, this is the minimum. Okay, and this is the sum of that temperature. So I'll just simply go back. So it is done. Okay, so our the first step is done. Now we'll go for our, we have found it our observed data. Now what we have to do, actually now we'll go for our prediction. Okay, actually how will be our temperature after 50 year or 60 or 70 year, how will be. So from here we'll be able to find out that data. So from we are here, actually one thing remember, I have take our analysis period is 2009 to 2019, that means 11 year. Okay, I have taken 11 year data as our analysis period. Okay, so I'll discuss about that later. So when it's done, now again I'll go here scenario generator. Okay, this is a scenario generator, and from here we have to change something. So now we'll find out our prediction data. Okay, so for that, what will be our prediction data limit? 2100, 21 years, and actually we have data till 2019, that I'll consider 2020. Okay, our prediction data will be start from 2020 to 21 year, 2020 year to 2001, right? So when it's done, I mean sorry 2100, I mean 2100 year here. So this is the data. Okay, almost 80 years. Okay, we have will found data almost for 8 years. So it is done and it should be 365. Okay, and everything is okay. Then I'll click save, then okay, then back. So when it's done, now I'll select output file, and from here I'll select the par file that we created, and from here they have many variable. Okay, GCM data. So with respect to, they have 3 data, RCP 2.6, RCP 4.5, and RCP 8.5. So you can read that from Google, the what is it actually. So I'm selecting RCP 4.5, and for 4.5 I'll create a out file. So from here I'm just taking a out file. This is Naglo temp maximum temperature, and I'll just give a name here for RCP 4.5. For RCP 4.5, okay, RCP 4.5, then open. So when it's okay, then I'll go click here, generate, yes. So here our file is ready. Okay, here our file is ready now. Wait to for that, it's saving. Okay, now I'll just go down, and from here again I'll click GCM data, and from here I'll select RCP 8.5. okay, actually it's required for you that for which RCP value you will create your prediction data. So I'm just working with 2, that's why I'm selecting that. So it's okay, but here I'll take some change. So or that I'll delete that dot what, and what will be, it will be for 8.5. okay, it will be for 8 RCP 8.5. so open. When it's okay, right, when it's okay, now again I'll click here. We have to confirm that yes, that is RCP 8.5, and here our file is also RCP 8.5. the name have okay, and view, it's okay. So I'll simply click generate, then okay, it's generated. This here there are 2 files again generated. So when it's done, we'll go for our next process. Then okay, sorry. So when it's done, now we'll go for again summary statistic. Now there you have to understand one thing. How will suppose if I told you I will find out maximum temperature for the time period of 2014, like that. Okay, 2040. okay, so first of all I'll select that art file. So first of all I'll create for RCP 4.5. okay, art file. Then when it's done, then I'll give a name here. I'll give the name, I'll just give name here like that, Naglo max temperature 2040. okay, for 2040 I'll find out our prediction data. So here I'll just give bracket for what, RCP 4.5. I'm just giving that name here because so that I can understand which data we're creating, and the file should be text file. Open. So when it's done, now here is the main thing, how we'll find out that analysis period. So I've told you that we have we have generated our analysis period for our observed data. For that, our observed data, that was for 11 year 2009 to 2019. So what we'll do actually, we'll also consider here 11 years. So how we'll take that 11 year, our 2040 will be the center year, and before that we'll take 5 year, and after that we'll take 5 years. So total 11 year. I hope you understand. And so actually you have data for 15 year, then you will take 7 year before and 7 year next, and the middle one will be 1 year. So total 15 year. Like that you have to select that data, and it's up to you actually. Suppose if you want to find out only for 1 year's data and you want to take the average of it for only 1 year data, so just understand what will be. You are you have a data of 2020, and you are you are finding out data for 2040. Then you are comparing your data with only 1 year, but you know that for climatic change that is not possible to compare for only 1 year or for only 2 year data, because we know that the climatic change happened with a big year. Okay, I mean um, after 10 years 20 years like that. That's why we have to take huge amount of data here so that we can compare perfectly. So here what we'll do, actually I'll take 2035 and I'll take a 2045. Okay, so 2035 to 2045, that is 11 year, and the middle year will be 2040. That's why I'm just telling we'll find out data for 2014. Actually we are finding data for 2035 to 2045, and we are comparing that range data with 2019 to 2019. So when it's done, now I'll simply click here, and it should be model, and I'll simply click analysis. Okay, so it's done. Actually when I have clicked analysis, then we have found two files. In similar way, you have to find out your wall data, right? I'm just clicking now back. Just if you click here, the main temperature. Okay, the main temperature, now you're seeing here the main temperature 13, and here it's showing us the main temperature. Okay, so I'm just going back. So actually that is for RCP 8.5. so if we find out similarly for RCP 8.5, that is 4.5, now I'll find out for 8.5. so I'll just come here and I'll just simply click here. So I'll just change that name 2040, but for RCP 8.5. so okay, and our date is okay, you know that our analysis period is okay. Now I'll simply click analysis. We'll found a file here. So here a file, I'll go back, and here is the main, maximum, minimum, variance, and sum. So when it's done, now for RCP 8.5, if we want to find out data for suppose for 8.5, if we want to find out data for 2016, 2060. Okay, so we'll select here 2060 like that, then open. After that I will give here again, I'll take 11 year, so that will be 65, and that will be 55. Very clear, that will be 55 like that. So because we'll take that year period with respect to our observed data, I mean with our field data. So view, it is okay. Now I'll go analysis. So I'll go back. Now actually after creating wall data that I required, actually I'll show you about that in Excel file, and we'll compare about that. So when it's done, now I'll just so that is 2060 for RCP 8.5. I'll take that data also for 4.5. okay, I'll get total 7 data. Okay, so this is for 4.5, and from here we have to select the 4.5 RCP hot file, and actually that value is okay. Now I'll go for analysis. So it's done, and I'll go back, and for RCP 4.5 we'll take also a data for 2018. So I'll just take data 2080, sorry not 18, 2080, open, and from here I'll take 85. So I hope you understand why I'm changing that date, and 75. So 75 to 85, that is 11 year, and the middle year is 80. That's why I'm taking the data like that. So it's okay. Now analyze. Okay, this is our analysis data. Then I'll go back, and finally I'll take for RCP 8.5 for 2018. I'll just change that name from here, actually I mean for 8.5, and we'll again analysis. So our name have changed 8.5, and for 8.5, and our data period is okay, analysis period, then analysis. So our all data is okay, right? Now I'll go back, and here I'll take a Excel file. So new, then Excel file. Okay, it's okay, and I'll open that Excel file to show our data. So I'm just okay, and I'll open our I'll open our the software. After that we'll go here, compare result. So I'll come here, and from here I'll just take our data. So first of all, I'll select our observed file. From here, open, and in that site I will take another file like 2040 for RCP 4.5. Actually, we have to compare all RCP 4.5 with observed data in one Excel, and in another Excel we'll compare RCP 8.5 data. So I'll just simply click OK. So we have taken two data, and what with respect to what we'll compare, we can compare with the sum, but for rainfall actually we take sum so that we can compare perfectly. But for temperature, that's no sense to have no sense actually to find out some temperature. Will take the main temperature, or we can consider the maximum temperature or minimum temperature, but I prefer to take main temperature, and also my professor told me to use that main so that we can get a standard value. So when it's done, now simply they have two options, line. So actually there is the line, okay, line graph, and with that graph we can understand that where our temperature is increasing and where our temperature, so if I actually where our temperature is increasing and where decreasing. Okay, but I prefer to bar chart, so I'll just take the bar. So here is the bar chart, and from here I'll simply click copy, and here I'll paste it okay, and I'll just do it like that. So when it's here, just see here, this is your observed 2020 to 2019 average temperature data daily, sorry, monthly, and here our average monthly data for 2040. But actually this is not 2040, this is 2035 to 2045, and I'm considering that 2040 for our for our prediction actually. So when that done, and also I'll take another two file. So I'll again select here the next one we have selected 40, so I'll take now 60 for 4.5, open, and in that site I'll take 80 for 4.5, open. So again when done, then main, and I'll select bar, I'll copy, and here I'll paste it in one, I will take in one box above, so here, and I'll delete that January because already have. So I'll select here and I'll select here. So just see here, now we have found our data. Here we have found our data monthly. Here's the month, and here's the year of analysis. This is the three box are of the three box data is our prediction data, and here is the observed data. So if I take a graph with that, if I select here insert, then if I go here, and if I take it like that, just see here, now we're seeing here the data actually that blue sign are representing uh, our observed, our the base data, and with respect to that blue chart will compare our other result. So if we see the next one is okay, that next one is representing that the temperature are increasing in 2040, and also it's at 2016 also increasing temperature, and 2018 it's also increasing. So almost in every station and every month we are seeing that temperature are increasing. And also we know that for our global from our global warming, we know that temperature will increase. That means, and how much will increase from here, actually we can predict that. Actually we cannot tell the exact value, but we can predict here. So that is for RCP 4.5, right? Now also we can take data for RCP RCP 8.5. okay, so similarly I'll just take data from there. Here first of all we'll take observe for both, and from here I'll take data for 2040 but for RCP 8.5. then I'll take main, here main, and I'll click bar, okay, then I'll copy, I'll just paste it here. Okay, it's here. Now again I'll just go that software, I'll back, and I'll select that RCP, that's for 60, okay, and for RCP 80, for 8.5. So main, and here also we'll take main, the line bar chart, then copy, then I'll simply paste it here. I'll delete the name of the month because already have. I'll take it here. So here our data now simply will take a graph. So here actually video are being very lengthy, so here I'll select it and I'll just take here a graph, and I'll see here. So for RCP 8.5 also, its temperature are increasing for all month also. So just in this way we can compare our data. Okay, we can compare our data with our observed data, and actually this is not a real data, this is a observed or predicted data. So you know that there have no one who can tell future, but by using that software we can predicted that we can predicted that how will be the condition of our environment or our climate in future. So thank you very much, and I hope that was helpful for you, and if you think that was helpful for you, please subscribe to our channel and also press the bell icon so that you get every update from us. And obviously like our video and leave a comment how was that video, and also leave a comment if you have any problem on it. So thank you very much. Stay connected till next video.